Hi everybody, this is Ian Sharp from Attis. Welcome to today's webinar. I'm going to be the moderator today, and our topic for today is 5G standards development in 3GPP, release 17 and release 18. And so we're going to give you a technical view of what's been going on in 3GPP standards work, to give you an understanding of the sort of new features in these releases, and also the value proposition that they bring. So we go to the next slide, please. So firstly, a quick introduction for Attis. For those of you who don't know Attis, we are an ICT standards development and industry organization based in Washington, DC. And the goal of Attis is to develop standards to promote interoperability to benefit industry and end users. We very much emphasize the use of standards as a platform upon which products and services can be differentiated. And we have a very wide and diverse set of members, including many different segments in the ICT industry. Attis does a lot of work in standards, specifically for North America and the United States, but we are also involved in a range of international standards activities. Specifically in the context of this webinar, we are a founder of 3GPP and we are the North American organizational partner for 3GPP. So we represent North American interests in that organization. So today we have some leading experts from the Attis membership who are going to share their information about 3GPP's work. So I'd like to move on and go to the next slide, please, and talk about the agenda for today. So our goal is to give you an update into the technical features that 3GPP has been working on. So we're going to start with a short introduction from me, and also I shall be giving some words in conclusion at the end. Then we're going to have Greg Schumacher from T-Mobile, who will talk about the services piece, followed by Puneet Jain from Intel, who will talk about system architecture and core networks. And then the last main presentation will be from Wanshi Chen from Qualcomm, who will talk about the radio access network. Please do submit questions via the chat during the webinar. We will try and answer those at the end of each presentation if we have time, or if not, we can try and answer them during the chat or after the webinar. Go to the next slide, please. In order to sort of help orient you in general, I'm going to give a few quick pieces of introduction about the structure and status of 3GPP. I think this will help you understand the presentations that are going to follow. So 3GPP, I think, is an excellent example of what's sometimes called Conway's Law, which is that organizations create systems that follow the same structure. And therefore, it's worth giving a quick introduction to 3GPP structure, as it's often referred to in some of the presentations that are going to come later. So there are three main technical specification groups, or TSGs, in 3GPP. The system aspects piece, SA, deals with the overall system design. And then we have core network and terminals, CT, dealing mostly with protocol work related to that. And then the radio access network, or RAN. And in Greg's presentation, he's going to talk mostly on the services piece from the point of view of the SA1 working group in the SA TSG. Then Puneet is going to cover how things look from the system architecture group in SA2, and also touching on some of the work done in CT. And then lastly, Wanshi is going to cover the breadth of the work done in the RAN groups. Next slide, please. So this slide is giving you a quick overview of the 3GPP releases. The focus for a lot of the technical discussion today is release 17, and we're focusing on that because it's now coming to the end of its development cycle in the standards process. And so this is transitioning from a standards work into a topic for deployment and product implementations. And that's heading towards protocol coding freeze in June this year. Following on from release 17 and already started in 3GPP's work is release 18. And this is going to introduce what has been termed 5G advanced in 3GPP. And this is reflecting the introduction of really the latest advanced technologies, including AI, ML, XR, and very high frequency bands into the 5G platform created in previous releases. And then we're also looking ahead a little bit to, or 3GPP is looking ahead a little bit to release 19, where requirements work has already started to take place. Next slide, please. So this gives you a bit more detail on the status of these releases. So as mentioned, release 17, we are really focusing on freezing the technical work apart from essential corrections and moving towards the protocol coding, sometimes called the ASN1 freeze in June. And this is going to be the focus of the RAN and system architecture presentations from Puneet and Wanshi today. And then Greg will talk more, I think, about the release 18 work and the sort of early requirements work on 5G advanced. That has already passed the significant milestone of having the work package, this is the overall scope, approved by 3GPP and is targeting approval in mid-2024. And then, as I said, release 19 is very much in the early phase of service definitions. So not to take any more time from our main speakers, that's all the introduction I wanted to give you. So I will hand you over to Greg Schumacher to talk about the services perspective from the SA1 point of view. So over to you, Greg.
Thank you, Ian. I'll start by giving a real brief introduction of myself in standards. I've been working on and off in standards since 1998 and pretty much full time. I have been working for Nextel, Sprint, T-Mobile since 2004, and have been involved with a number of 3GPP standards. Most recently, my focus has been on SA1 and SA3, and recently was SA1 Vice Chair and SA Plenary Vice Chair, as well as being involved with a number of ADA standards in PTSC and WTSC and several TOPS console projects, including one coming up about zero trust in 5G. So with that, can we go to the next slide? So what I wanted to start out with is to kind of highlight what is SA1's role in the waterfall effort in 3GPP. And this is paraphrased from the SA1 scope, which has been updated in the last year or so. So it develops the new and enhanced services, features, and capabilities for the 3GPP specifications, and as well as interworking with services defined by other SDOs, which are external to 3GPP. That is the primary function, and once those services, features, and capabilities are defined, then it's passed off to the other groups to develop the architecture and system requirements. It's in addition to defining the requirements and services, it's also the designated entry point for vertical markets to bring in their needs into the 3GPP for support by the 3GPP technologies. And this, when I mean verticals, these are business lines or business markets that are outside of the traditional telecom mobile communication that is 3GPP's core focus and its traditional focus. There are two verticals which have been involved a little bit longer in 3GPP before 5G, and that is public safety as well as railroads. But I will not be focusing significantly on those verticals. So SA1 defines the stage 1 requirements for these downstream groups, and the way we usually do it is by first coming up with the use cases for the services which illustrate what the 3GPP network and capabilities should be able to do in order to support those services. And once we have the use cases, we then come up in the studies, the potential requirements that the use cases highlight. And once the study is complete, those are all consolidated because oftentimes they're duplicates, as well as requirements that are already satisfied by the existing specifications. And those are then consolidated and will be used to produce the normative requirements that go into the actual service specifications. The use cases and potential requirement documents, the TRs, have a limited lifespan, probably for like 3 or 4 years. Once the service is in place, there's usually not much need to go back and look at them, but they are important for the initial definition. Next slide, please. So given that, what SA1's role is, this is a recap with a little more detail from my last presentation on SA1's work, where this list illustrates the main work areas that we had undertaken to cover in SA1. And so you can see that it was very significantly focused on new verticals. The AV production, warehouse, medical verticals, drone verticals, satellite verticals, a few that covered multiple verticals, industrial and factory verticals. And then there were a couple of items that were targeted for the traditional mobile and communication telecom business. Now, these, I'm not going to go into these in any detail because they're so varied, but the 3GPP has undertaken the effort to produce a high-level description of all the new capabilities that are developed for each release. And so the document that will cover release 17 is TR 21917. If you go in and find it, you will find that it's pretty much in a skeleton form now, where it has all the capabilities that are being added to release 17 beyond release 16. Now, the reason for holding off on producing it until after we actually complete the release is that if you go and study these study item descriptions and the work item descriptions, those are the contain the goals and scope of the projects. But oftentimes there's variance. Some of the aspects are not covered, or they come to different conclusions, or the work is not pursued, or things like that. So this reflects what we actually produce and not what we, and so it should illustrate it won't highlight, but it will show you the difference between what was intended that's described in the study items and work items and what we actually accomplished. So will probably be completed around about 6 months or so, where the individuals responsible for each of the items that's in there will be contributing the description of their piece of the release. Next slide, please. So now, so that was a highlight of release 17, and that's not all of them, but those were the more significant work. Now, one of the, I think the main takeaways between 17 and 18 is that 17 focused on a select set of verticals, like the factory, like medical and things like that. Whereas 18 was more of filling in there were a couple of vertical specific activities like the smart energy and the infrastructure, which is targeted for the smart power grid vertical, and a couple of satellite verticals. But more of the work was focused on providing services across multiple verticals, and less of specific verticals. So these were the projects that we covered that I would consider vertically oriented, or bringing in new verticals into being supported by 3GPP technologies. Next slide, please. So these are the work. This is the work that SE1 has accomplished and covered in Release 18 that's not targeted to specific verticals. And as you can see, we've returned back to a number of mobile and wireless and telecommunication services, like IMS evolution, the enhancements to network slicing, the residential and personal networks. So I think the conclusion that I would take is that Release 17 was a big rush and flood of new verticals. Release 18 had some new verticals, but it was a little more balanced. And we will see what Release 19 looks like. So these are these two slides represent the majority and the more significant projects that SA1 undertook, and the studies and normative text is all complete. Next slide, please. So now SA1 is starting to look at Release 19. I don't have any slides of the actual work that we're undertaking because we're still in this. If you see the gray box, the SA1 content definition, we're still in that period. And so some projects which got approved are starting up conditionally on the overall workload, and we expect to have more work to discuss and agree upon this coming quarter. And as you can see, our target is to get to 80% in the second quarter of 2023 and complete Release 19 at the end of the third quarter in 2023. This is subject to overall 3GPP schedules, which often are driven by other external forces, but haven't really been discussed at this point. So this is the SA1's best effort, and some of that right now is targeted by the SA2 schedule, where we want to be relatively stable Release 19 when SA2 starts thinking about Release 19. Next slide, please. So this is in a written form, the milestones that we're working towards. We have had 26 SIDs that have been presented, only 6 agreed in the first quarter. It's clear that if we were to agree upon all 26, that would be too much for SA1. After the second quarter, there'll be a analysis by the SA1 leadership to determine whether we need to prioritize, and there may be a prioritization effort. And then the next are the milestones for the expected milestones for release 19 and SA1, subject to overall release 19 considerations. And I believe that's all I have. Next slide, please. Yep, that's it. I will return it now to Ian.
Okay, thanks, Greg. That was helpful to get that update. So I don't see any questions, but if you have further questions for Greg, then please put them in the chat and we can try and get to them at the end of all the presentations. But then in the interest of time, what I suggest that we do is we move on. So I introduce you to Puneet Jain from Intel, who is the 3GPP SA2 chair, so a very important role in the systems work in 3GPP. So Puneet, do you want to introduce yourself quickly and talk us through your work in SA2?
Sure, thank you very much, Ian, and thank you, Etis, for this opportunity. Hello, everyone. My name is Puneet Jain, and I'm currently 3GPP SA2 chair. And recently, we just 2 weeks back, we had a 150th meeting milestone of an SA2. So basically, SA2 has completed 150 meetings. The first meeting was in 1999. The first one hosted in San Francisco, and we have come a long way since then, defining the 5th generation of technologies for mobile broadband. So I will talk about the system architecture and Codeword network enhancements in 3GPP release 17, and will also briefly describe release 18 developments in SA2. Next slide, please. From a system and standards perspective, 5G is designed to be both evolutionary and revolutionary. Initial 3GPP 5G release focused on enhancements for mobile broadband market and its use cases. Release 15 delivered baseline NR functionality to meet eMBB and URLLC requirements of 5G technology. Also, all new 5G core network was defined using service-based architecture principles and several innovative features such as network slicing, enhanced QoS support, network capability exposure, and seamless integration with non-3GPP access network was defined in Release 15. Release 16, also known as 5G Phase 2, was continuation of Release 15 with an objective to fully address the original 5G vision. It added several features and services for vertical, enterprise, and mission-critical applications. Release 17, which is planned to be finished by June 2022, will provide further enhancements to certain Release 16 features, as well as enabling new features and services. It will add new capabilities and enhancements for enterprise, vertical, and consumer services. Next slide, please. Although SA2 kicked off work on Release 17 study items in the 4th quarter of 2019, the major part of the work has taken place after the Release 17 prioritization exercise, which happened at TSG SA89 plenary meeting in December of 2019. Overall, Release 17 is more evolutionary in nature. Release 17 expands the market reach of 5G technology. This includes new features such as 5G for satellite, IoT services, public safety and mission critical services, support for edge computing and interactive cloud services, and support for unmanned air services. Release 17 also addresses additional requirements for mobile operators and verticals, which includes enhancement, performance, and efficiency improvements targeting industrial, V2X, massive machine type communication, and EMAB use cases. Network evolution features such as network slicing enhancement, integrated access backhaul enhancement, etc. is also part of Release 17. It is also worth mentioning that during Release 17 development, a lot of effort was also spent on stabilizing Release 16 5G system specifications. In the next few slides, I'll talk about some of the Release 17 enhancements in more detail. Next slide, please. Edge computing is supported in 5G system architecture since Release 15. In Release 17, 5G system supports the 3 connectivity models to enable edge computing: distributed anchor point, session breakout, multiple PDU sessions are 3 connectivity models based on location of connectivity and PDU session anchor UPF. In Release 17, mechanism for discovery of edge application server was defined. Before an application or UE starts to connect to a service, it is very important for the application or UE to discover the IP address of one suitable application edge server, so that the traffic can be locally routed to the edge application server via uplink classifier or branching point mechanism that were defined in Release 15, and service latency, traffic routing pattern, and user service experience can be optimized. Edge location is also an important issue to tackle. With edge computing being deployed in 5G system, UE mobility and application server relocation needs to be considered when designing solution for optimal deployment of edge solution. For example, as the UE move across the 5G system, the UE location may change and require the network and the edge to deal with the change of UE location. 3GPP Release 16 specifications already added some of these aspects, and Release 17 provided additional improvements. Another enhancement in Release 17 was about network information provisioning to local applications with low latency. With edge computing deployed, it is expected that set of edge computing functions or edge application servers running on edge hosting environment will need to interact with 5G system to access 5G functionality or to provide information to 5G system for provisioning of connectivity services supporting edge computing. Latency of network exposure needs to be considered. For some network information to be exposed, the long exposure latency is tolerable. However, some real-time network information, such as network congestion condition or real-time user plane latency, can change very frequently. So in order to address that, it's in Release 17, network information provisioning to location application with low latency was specified. Next slide, please. Work on edge computing has been progressing in both SA2 and SA6. SA2 defined network layer solutions to support UE connectivity with EAS, while SA6 defined middle layer platforms for edge computing. SA2 and SA6 has been developing complementary solutions for the EAS discovery, although on the different layers. SA2 defines EAS discovery using DNS, while SA6 has defined EAS registration discovery via middle layer. SA2 and SA6 has defined complementary solutions for edge relocations and network information exposure from 5G course to application function. Next slide, please. Enhanced support of non-public network was specified in Release 17. For industrial IoT use cases, Release 16 defined a non-public network, which is a 5G system deployed for non-public use. A non-public network may be deployed as a standalone non-public network, in which case it is operated by a NPN operator and not relying on the network functions provided by a PLMN. Or a NPN may also be deployed as a public network integrated NPN. Release 17 added support of SNPN with subscription and credentials owned by an entity separate from SNPN. This entity is called credentials holder. Release 17 introduced a broadcast information that an SNPN supports separate credentials to support network selections. A new network function called network slice specific and SNPN authentication and authorization function, in short, NSSAAF, was defined. NSSAAF supports network slice specific authentication and authorization and access to SNPN using credentials from credential holder using AAA servers. Release 17 also added support for UE onboarding and provisioning for SNPN. Also, support for IMS voice and emergency services for SNPN was defined in Release 17. Next slide, please. Release 16 added support for time-sensitive communication services to support deterministic and/or isochronous communications with high reliability and availability. In Release 16, main focus was on integration of IEEE time-sensitive networking. In Release 17, the 5G system expanded the support for time synchronization and time-sensitive communication for any application. Release 16 supports only downlink synchronization, that is the scenarios where TSN grandmaster clocks resides on the network side. Release 17 added a support for uplink time synchronization where TSN grandmaster clock can reside on the device side. Release 17 also defined TSC assistant information, which describes traffic characteristics that may be provided for use by G-Node B to allow more efficient scheduled radio resources for periodic traffic. 5GS determines TSC assistant container based on the information provided by the application function or NEF and may provide it to the PCF for IP type and Ethernet type PDU sessions. Survival time was also introduced as part of TSC assistant information in order for the application function to provide the time period an application can survive without any burst. Next slide, please. Release 16 provided support for network automation and data analytics. Network data analytics function, NWDF, was defined to provide analytics to 5G core network functions and ONM. In Release 17, NWDF functionality was further enhanced and decomposed into two separate functions. First one is an analytics logical function, ANLF, which provides analytics to 5G core network function and ONM. And the second function is model training logical function, MTLF, which provides trained model and exposes new training services with other NWDFs. Pre-trained machine logic model storage and provisioning to NWDF is outside the scope of 3GPP in Release 17. In Release 17, distributed NWDF architecture is supported. An NWDF can act as an aggregate point and collect analytics information from other NWDF that may have a different serving areas to produce an aggregated analytics. In Release 17, data collection, coordination, and delivery is supported to prevent data sources from having to service handle multiple subscription for the same data and send multiple notifications containing the same information due to uncoordinated requests from data consumers. Next slide, please. ATSSS feature enables a multi-access PDU connectivity service, which can exchange PDUs between the UE and data networks by simultaneously using one 3GPP access network and one non-3GPP access network and two independent N3, N9 tunnels between the PSA and RAN. The multi-access PDU connectivity services is realized by establishing a multi-access PDU session, which is a PDU session that may have a user plane resources on two access networks. In Release 17, as part of ATSS Phase 2, support for additional steering modes with potential PMF extensions was supported. During the study phase, there was a discussion on additional steering functionalities based on ITF protocol, Quick and Multipath Quick. However, due to the lack of progress in ITF, that was not standardized in SA2. Support for multi-access PDU session with one 3GPP access leg over EPC and other access leg over non-3GPP access legs in 5GS was also specified. Next slide, please. The architecture enhancement for UAV introduced a new functionality, including UAV identification, UAV authorization by UTM, UAV and UAV controller tracking, UAV authorization revocation and reauthorization features, UAV controller and UAV association, and user plane connectivity for UAVs. UAV tracking supports 3 UAV tracking model, which includes UAV location reporting mode, UAV presence monitoring mode, and the list of aerial UAVs in a geographic area. The 3GPP system does not provide any specific geofencing or geocaching mechanisms, but 3GPP system provides enablers to support geofencing and geocaching functionality in USS, such as location services, enablement of command and control connectivity, and event notification to subscribing USS, etc. Next slide, please. In release 17, 5G proximity-based services are supported, which includes PROSE direct discovery, support for NRPC5 PROSE communication, support for UE2 network relay, support direct communication path between PC5 and UU, support of PC5 service authorization and policy parameter provisioning. Next slide, please. "5G multicast broadcast services" was also specified in release 17. This feature provides 5G architecture for general 5G multicast and broadcast communication services, enabling, for example, transparent IPv4, IPv6, multicast delivery, IPTV, software deliveries over wireless, group communication and IoT applications, V2 applications, and public safety. I would not have a time to go through in details of some of these features, but most of them are listed in this slide. Next slide, please. Release 17, 5GC location services provide support for very low latency and very high accuracy positioning, including horizontal and vertical positioning services level, 5G positioning service area. It provided a support for UE positioning capability storage in AMF, multiple QoS class, non-3GPP support for UE position, scheduled location time, and satellite RAD type in LMF selections. This work item also enables mission-critical UEs to use 5G positioning services to determine its position. Next slide, please. There have been several others release 17 enhancements. 5G AIS, which stands for Advanced Interactive Services, defined a new standardized 5QI corresponding to QoS requirement for interactive services like cloud gaming. Multimedia Priority Services, Phase 2, address impact of EPS and 5G core network specification for supporting multimedia priority services for MMTEL video voice conferencing, MPS data transport services communications, and MPS for MMTEL video. Architecture enhancement for 3GPP support for advanced V2X services provides a support for QoS-aware NRPC5 power efficiency for pedestrian UE. Architecture aspects using satellite access in 5G system was also specified as part of release 17. System enabler for device having a multiple USIMs provided support enhancing for handling mobile terminating services with multi-UCM devices, enabling the paging reception for multi-UCM devices and coordinated leaving of multi-UCM devices. There were several enhancements for network slicing was also specified in release 17. On the right side, what you see is basically some of the work which was done in SA2 as part of RAN-led features. One of that was architecture enhancement for NR reduced capability devices. These reduced capability devices aims to support devices with capability between NR IoT, eMTC, and eMAP. These target IoT use cases such as industrial sensor, video surveillance. Interest in wearable devices use case is growing. Then the last but not the least, there's also a feature which was led by CT on minimization of service interruption, which was specified in release 17. Next slide, please. Now looking forward, there is a strong 5G evolution path in 3GPP with many more capabilities yet to come. Last year in May, 3GPP officially labeled release 18 and after as 5G Advanced to signal these future releases and work being done to make 5G even more capable. In release 18, currently SA2 has 27 study items and work item in progress. These are a very huge number of study items as compared to any past releases in 3GPP, especially in SA2. Some of the release 18 study items is a continuation from the release 17. So many of the things which you see as either phase 2 or phase 3 are actually following the work which was done from the previous releases and building on top of that. However, there are some new capabilities which are also being added in release 18 based on the stage 1 service requirements which Greg talked about. Some examples of these are the system enablers for service function chaining, study on extensions to TSC frame to support DetNet, which is our going in ITF, then a study on vehicle mounted relays. There's also a study going on the personal IoT networks, which again is based on the service requirements from SA1. And another interesting is study on extended reality and media services, also based on stage 1 requirements. What we see is release 18 is embracing AI/ML to the fullest extent. There was some work done on data analytics, which we had talked about in release 16 and 17, but now study on system support for AI/ML based services is also ongoing in release 18. So this will talk about, this will try to address some of the aspects on federated learning and things like that. Release 19 is still under discussion in stage 1. So far there has not been any activity in SA2, but we expect, as what Greg mentioned about the timelines for release 19, which are still very preliminary. And once we have a stable service requirements, then at that time we'll have a discussion on stage 2 aspects for release 19. And we expect that would start sometimes next year in 2023, towards the later or second half. With this, let me hand over back to Ian. This concludes my part. Thank you very much.
Okay, thank you very much, Praneet. Really appreciate that. I mean, when I started 3GPP, it was like a single access technology for voice and SMS, and now we look at the many ways we're integrating with other technologies and addressing different vertical segments. It's a completely different environment from the sort of 3GPP we're used to know. I think we've got time for 1 or 2 questions, so let me try and pick a couple out of the list here. So one question was regarding MEC. So could you perhaps comment on the difference between the 3GPP work on MEC, or the relationship between the 3GPP work on MEC and what ETS has been doing there?
So the most of the work is basically on a Mac, and interworking with the Edge app is going on in SA6 currently. So SA6 has a work called Edge app, and that's looking into the interworking aspects with the Etsy Mac, as well as also looking at some of the aspects related to GSMA operator. I'm forgetting the name. There is something on operator platforms. So they're basically trying to have the whole system designed based on 3GPP Edge app and SA2 Edge work with the Etsy Mac and also with the GSMA operators platform.
Okay, thank you. And then another quick question. One of the features that we've talked about is the sort of new work on broadcast multicast, and that sort of was something that had been done historically in 3GPP and maybe not had very active deployment, or at least certainly not for consumer type services. I guess the question is, do we kind of believe that the sort of second take on that topic is going to be more successful or be more effective in addressing use cases? Do you have any thoughts on that question?
That's a very interesting question. And yes, I think it's very right that there has this actually is a third attempt, not the second attempt to have this multicast broadcast services, I mean, it has been specified since 2 generations, and this is the third attempt. And again, the jury is still out whether we'll see some deployments in the real world scenarios. But I can only say that I'm optimistic, and maybe it's something which operators would take into consideration, the new features coming in 5G, to consider 5G multicast broadcast services for the real land deployments.
Okay, thank you. So I think in the interest of time, there's a lot of questions on the chat, and if speakers want to go in there and answer some, that would be great. But I'm going to hand you over to Wanshi Chen, who is chair of TSG RAN, and amazingly a difficult job managing all of the activities on Radio Access Network. I think some of the questions that have been asked are also relevant to his presentation, so I hope we'll have time at the end of that to bring up some of those. So I'll hand you over to Wanshi to talk us through the RAN activities. So over to you, Wanshi.
Okay, thank you, Ian. Thank you, everyone. Good morning, everyone. My name is Wanshi. I'm currently 3B TSG RAN Plenary Chair. Next slide, please. Yeah, so the agenda of my presentation will start with where we are now in terms of 5G. Then I'll spend most of the time to give you guys a presentation on Release 17 from RAN perspective. And then we'll briefly discuss a little bit on Release 18, the start of 5G Advanced, and followed by questions. Next slide, please. So these slides, for some reason, some of the words are not that visible, but this slide try to give a good summary where we are in terms of the 5G commercial deployment, and also we use the wording accelerating globally. This is more referring to the commercial deployments and adoption of 5G NR. Just let me verbally present some numbers to give you a kind of overlook of where we are right now. So we have over 205 operators already with 5G commercial deployments, with the more than 280 additional operators investing in 5G. In 2022, they're expecting to have 750 million 5G smartphones to ship, and then we're going to have predict to have more than 1 billion 5G connections by 2023. This is actually faster than 4G adoption, 2 years faster. And we also predict to have more than 5 billion 5G smartphones to ship between 2020 and 2025. There's also more than 1,200 5G design launched or in development. So all these numbers just give you indication about the 5G acceleration in the global manner. Next slide, please. So this slide try to provide from timeline perspective where we stand. As we all know now, we're just completed release 17, which is the third release of 5G NR. We started release 15 more or less 5 years ago for the first release, release 15. And then release 16 will have expansion to vertical domain, which will be which are now also further expanded in release 17, which are going to provide more details. And we actually just prove the so-called run release 18 package in December last year for run 2, run 3 led projects, and also more or less 1 month ago also proved the projects for run 4 led projects in release 18. And this is target for 18 months release for release 18. And I think Punet also mentioned the future releases, similar things also will happen in the future. Of course, we don't know what the exact timeline for release 19 and future releases. But we still have a lot of things ahead of us to further enhance and improve 5G NR. Next slide, please. So this slide tries to summarize the projects we just completed from a functional perspective, covering into 2 aspects of release 17. One we like to call new and enhanced 5G system capabilities. So it's more like these traditional enhancements. And then we also have this so-called expansion to the new 5G devices and applications. So here you can see on the new and enhanced 5G system capability, we have this usual suspect, this fully enhanced Mason Mimo, which is enhanced in every single release so far. Then we also have car enhancements. We have this device power savings. And then of course spectrum is always an important aspect. So we have this expansion to 60 gigahertz. And then we have topological enhancements in terms of enhanced IAB, which is called integrated access to the backhaul, and also have RF repeater. There's also further enhancements on YRC, private networks, and many others. On the expansion side, we have Starlink expansion, which also one critical part for the entire system. We also, I think also just presented earlier, we have this broadcast multicast expansion. Red Cap is also known as NR Lite, basically to try to address more use cases along with the continuing enhancements for the legacy, if you will, IoT standard, something called eMTC or NIBRA IoT. On the NTN side, we also have these enhancements, and this is not just in terms of NR, also in terms of IoT aspect. And positioning got fully enhanced. And then we also have this XR study, which is one important use cases for 5G NR. Next slide, please. So I'll start with introducing this first aspect, basically new and enhancing 5G NR. Next slide, please. So the first project, as mentioned earlier, it is Mimo Performance. So we of course we had the first 5G release already had a lot of components for Mimo operation, which is one critical technical enabler for 5G performance. And this was fully enhanced in release 16. Now in release 17, we do have more enhancements, particularly focused on these 4 areas at least here in terms of enhanced multi-beam operation, SR's improvement, and also this enhanced multi-TRP deployments, which is also known as COMP. It's basically cooperative transmission or reception when multiple transceiver points are actually involved. to serve a particular user. We also have full enhancement for channel feedback, the CSI measurement and reporting. And this Mimo is always a very involved discussion, very technical, and this also will be further enhanced release 18. Next slide, please. One particular aspect for 5G is about coverage. This is typically, for both 4G and 5G, typically the limiting link when you compare downlink and uplink is that the uplink typically is the limiting one. So we now have this uplink coverage enhancements in release 17 with a specific user case in mind in terms of the data rates, the deployment scenarios. They're also showing here, we're targeting both urban and rural deployments, covering both the so-called FR1 and FR2, and then also apply to the NTN communications. So that enhancements are reflected in the three different aspects. One is of course the uplink data channel, which is one of the primary focus areas, and then we have the uplink control channel, which is also important to enhancement to make sure the reliability can be increased. And then lastly is so-called message 3 enhancements. This is part of initial access, and this is try to make sure that this capability can be early indicated, and also to make sure the initial access can be more robust. Next slide, please. And Power 7 is always an important aspect especially for the user side. And we already have enhancements in release 16. This is a continuation to further exploit these Power 7 opportunities, not just for the connected state, but also for the idle inactive state. So this in terms of to provide this potential, the so-called tracking reference signals, or CSRs reference signals for UEs in idle inactive state. And also we have this PDCC-based PEI. I think there's some type of there. PEI actually stands for paging early indication. So this is try to further improve the power for the paging related operation. For connectivity mode, we have further enhancement in terms of extending receiving DCI. This Power 7 adaptation for active band part, including the so-called PDCC monitoring skipping. Essentially, try to opportunistically skip monitoring of the PDCCH, the control channel, whenever possible, to further improve Power 7s. And also further relaxation in terms of mobility management. This is RLAM and also BFD. The BFD stands for beam failure detection for low mobility devices, and also with so-called short DRX cycles. Next slide, please. These slides try to provide a summary of one important project on the spectrum side. So as we know, we have something called FR1 and FR2. FR1 is the spectrum covering the carrier frequency up to 7.125 gigahertz. We also have this legacy, if you will, FR2, which cover 24 to 52.6 gigahertz. Now we expand this, further expanded to we also call 60 gigahertz, but essentially is from 52.6 to 71 gigahertz. But now we combine this FR1, the legacy FR1, and this new expanded spectrum now called FR2. So legacy one now is relabeled FR2-1, basically from 24 to 52 gigahertz, and the new one in release 617 now it's called FR2-2, which is 52 to 71 gigahertz. And of course, to support operation in this new band, so that there's a lot of things we need to consider. And down the bottom, you can see a few things listed here: the subcarrier spacing for control data channels, the sync channel, the sync signal block, the pneumology, the channel access mechanism, which is covering different flavors of LBT. LBT stands for listen before talk. And then you also have a careful beam measurement related to the enhancements. Next slide, please. Next slide, please. I haven't seen the next slide yet. Maybe a little bit too slow. Okay, now it's it. So ULRC. Now I heard some echo. Okay, so ULRC is one important pillar, if you will, for the original 3 user cases envisioned by 5G NR. This was some limited support was done in release 15, and then in release 16 we have a dedicated work item to enhance the ULRC, and this work is being further done in release 17, covering these 5 areas as listed here. One, the physical layer channel feedback essentially is a half feedback, basically to try to improve half feedback for some cases, especially related to the so-called SPS operations, and also some other CSR feedback enhancements. And also there's also great work on improving this compatibility. Sorry, can you move back? I haven't done that yet. Yeah, also improve compatibility for unlicensed spectrum, and also intra-device multiplexing and prioritization. This is basically to address the case when the channel signals may have different priority, how to better multiplex them together for the single transmission. And then enhanced time synchronization is address the case where we want to have this time sensitive network to address this case when the round trip time is actually large than a particular threshold, and also the enhancement on the network side. Next slide, please. So these are 2 aspects in terms of topological enhancements. One is the alpha repeater, the other one is RAB. Alpha repeater is kind of a new item in release 17. This is something very basic repeater, if you will. There's no adaptive beamforming, and this part will be done in release 18, something called smart repeater. IB is our continuation. There's already some work already done in release 16, and release 17 further enhance IB to further improve this aspect. This also got further enhanced. Will be further enhanced in release 18. Next slide, please. So now let's move on some introduction of the expansion part. Let's move to the next slide. And one particular aspect I think Björn also mentioned earlier is about reduced capability. This is try to address some additional user cases. I'm not going to go through this as already mentioned earlier. Essentially, the idea is try to de-featuring, if you will, of the features that we already specify for smartphones, and to try to simplify, to reduce complexity, so that we can better address some new markets with targeted user cases. Next slide, please. Yeah, so this is try to give some more details, like what has been done in terms of the power, the lower device complexity. For example, the bandwidth in particular. So it used to be, we have FR1 that we present earlier. For that kind of band carrier frequency, we're talking about 100 MHz bandwidth requirements, more or less. For FR2 is 400 MHz. So this now is being reduced. Basically for FR1 from 100 to 20, from 400 to 100 for the FR2 case. And also there's many other specs, fewer numbers antennas, half duplex, all the kind of different things. And also transmit power assumption, this increase network efficiency, coverage optimization, all these different aspects. Try to address this targeting these new user cases. Next slide, please. So this is another aspect on IoT. RedCap is much in the way kind of addressing high-end user cases, but this is the continuation of the low-end, if you will, the IoT parts. We have two flavors, the eMTC and also NeverRT. And this work has been done, let's say, non-stopping for quite a few releases. If you see the chart here, you can see it's starting from the original work release 13, which is a long time ago. So it's got continuous enhancements over the past years. In release 17, in particular, you can see that the throughput got fully enhanced for both eMTC and NeverRT. Next slide, please. So this is the NTN aspect. This is satellite communication, also called non-terrestrial networks. They come with two flavors. One is NR, which is more like smartphones or CPEs. Then we also IoT aspect. So we got, I mean, the one primary issue you can imagine is just because of long round trip delay. So that part got a lot of enhancements, try to address this uniqueness of NTN communications. IoT has tried to fully improve the coverage and to support more diverse use cases. And the original list was targeted just for start item, but then the need to have at least a very basic location for IoT later become so strong. Eventually, the start item got completed earlier, and then this was further specified as a work item, and this also got done in the 17. Next slide, please. So this is Starlink. It is also one important aspect. So we have this traditional so-called U-Link. We have the Starlink PC file link. This already done in release 16, particularly focused on V2X and public safety. And now in 17, this was fully enhanced, particularly in terms of even more coordination, in terms of this resource allocation, try to have multiple ways to do some coordination for better resource reservation, and also power saving enhancements, because there may be used to be just focus on vehicle power is not issue, but now we may also have pedestrian V2P, vehicle to pedestrian communication, and stuff like this. That's become critical to also consider power saving aspects, and also new Starlink frequency bands, the geography confinements, and then lastly is also this Starlink relay, which is also an important part to further improve or mitigate coverage related issues. So this come from both layer 2 and the layer 3 aspects for Starlink relay. Next slide, please. And positioning is also critical aspect. We already have release 16 to establish a very good foundation for positioning, which specify many different flavors of techniques for positioning, including round trip time, the angle arrival, angle departure, the time difference of arrival, single cell positioning, all the kind of different things. This made it possible to achieve accuracy in a few meter level, like 3 meters, 10 meters, if you look at 80% percentile of the time. And this was fully enhanced with 17, enabling us to be able to achieve centimeter level accuracy. In particular, for IoT, it can achieve even less than 20 centimeters within 100 milliseconds. Another aspect I think you also mentioned earlier is about the latency for positioning. So not only in terms of accuracy enhancement, it's also important to improve the position latency as low as 10 milliseconds. And also efficiency, because the positioning has to also multiplex with many other services. Efficiency also important, and also GNS enhancements. And of course, this positioning also got further enhanced in release 18. Next slide, please. So this slide talk about XR, and this is also probably one of the most interesting user cases for 5G NR. It is also important for us to understand better how the existing 5G NR network can support these services. To do that, we had this study item release 17 to look at how the current system performs by looking at the very detailed traffic requirements and evaluation methodology, covering many user cases. I can see on the left-hand side the few use cases listed here, including distributed computing, split rendering, viewpoint-dependent streaming, conversational XR, cloud gaming, all the different aspects. Of course, eventually was reflected by a set of simulation parameters. And also we talk about different KPIs to try to characterize different performance for different use cases and carry out all the performance evaluations. And also try to also have some limited work on the potential enhancements. This is will also further be started in release 18 with some study phase to further look at more detailed the candidate techniques and eventually the targets to specify these enhancements in release 18. Next slide, please. So that's also the aspect about broadcast. And also there's some questions about how the current situation for broadcast from both commercial and standardization perspective. I think these all the things is not new in terms of the necessary to specify some enhancements. This come also in different two different flavors. One is standalone broadcast, which also been specified for a few releases and further enhanced in release 17. It is also called LTE-based 5G terrestrial broadcast. Another flavor is called MBS, Multicast and Broadcast Services. That enable us to be able to have this dynamic switching between unicast and broadcast, and also have some very detailed, let's say, efficient enhancements, try to supporting uplink half feedback and retransmissions. Look at this link adaptation and reliability. Next slide, please. There are also many other RAN projects. For the sake of time, I'm not going to go through one of them, but you can see there's a long list. Many of which also can be classified either as a new or continuing enhancements or expansion to other domains. Next slide, please. So I like to spend a little bit of time to see how this will bring us to the next steps. I think I also mentioned earlier, we enter 5G Advanced, starting from release 18, and there's a lot of discussion on 6G outside GPP. So it's also important for us to have a really good start of 5G Advanced in release 18. Next slide, please. So again, for the 5G Advanced evolution, which is the second phase 5G, there are many things that we need to consider, and this picture try to give more or less a pictorial illustration of the stuff we need to consider. I'm not going to go through the details, but indeed, this is at least personally, I'm very happy to see further expansion of all different areas for us to consider for the standard evolution. Next slide, please. So on a high level, this slide summarizes the this release 18 package or the 5G evolution in release 18. As I mentioned, it's already approved in December for Run 2, Run 3 led projects, and in March for Run 4 led projects. So overall, I think the wording balanced is a very good description of the overall package, and this balance is reflected in 3 different aspects: this mobile broadband evolution versus further vertical expansion and balance, and also the balance between immediate commercial needs with a longer-term 5G vision, and also this balance in terms of new and enhanced devices versus network evolutions. Next slide, please. So due to limited time, I'm not going to go through the details, just to try to highlight a few projects. This is by no means to be exhaustive list, but just a few projects to illustrate what has been improved. Also quite a lot of projects. Again, here we have this 2 columns. One is to try to strengthen at least this rough categorization to strengthen the end-to-end 5G system foundation. And the other one is proliferate 5G to virtually all devices and use cases. On the first column, we have this full enhancement for downlink MIMO and uplink MIMO. Uplink enhancement actually is one critical aspect that many companies actually are very interested in to enhance in release 18. Enhanced mobility and also mobile IB, smart repeater. This IB, as mentioned earlier, already have 2 releases. Now we also consider the case when IB itself may be mobile, maybe moving. And now how the repeater is enhanced from the F repeater mentioned earlier to make it smarter, to be able to do beamforming and take into account some TDD configurations, kind of things. Evolve duplexing, we're talking about the possibility to transmit and receive simultaneously in the TDD spectrum, although they may be on different subbands. Then one probably very interesting aspect is the AI machine learning. For the first time, now we'll also consider how to integrate AI machine learning into 5G NR. We'll start with the study item release 18 for this aspect. And I have green networks. This is consider the case when how to better to have this green operation for particular focus on GNB, of course, with hopefully not too much impact on UV side. On the second column, we have this, as mentioned earlier, XR will be start with a study item. Hopefully, also have some specification down release 18 to improve XR services. And the red cap also got further evolution in release 18, focus on even smaller bandwidth to address to optimize for some other use cases. Then Starlink got further expanded, not just in terms of the services, also in terms of spectrum, unlicensed spectrum, additional beam enhancement of different flavors. Positioning also got further expanded. Beside all this accuracy, latency, all the different things, also Starlink positioning become one important part of it. We also have drones, this uncrewed aerial vehicle, and also for the enhancement for NTN for both NR and IoT aspects. And lastly, also Multicast and many other enhancements. I think this is the end of my presentation. Thank you so much.
Yeah, thank you, Wanshi. Very informative presentation. I think we have time for one question, and then I will need to present the wrap up. So one question that I think has a lot of general interest. Could you very quickly talk about the relationship between 3GPP and Ohran? Because I think people get very confused about this, and I'm sure they'd like to hear your view on that.
This is a very good question. I think I got the same question multiple times. I mean, 3GPP in general is open and global standards. I think definitely any new proposal welcome, and Ohran is no exception. But this topic Ohran, as we all know, is definitely a very sensitive topic. Indeed, in release 18, there were already one project that we also approved. It's a very short study item led by Run 3. It's called the GenoB CU Resilience Enhancements study, actually. So we'll try to see whether there's some issues in the current this architecture, particularly this DU connecting with CU, whether any issues, whether something can be enhanced. I can tell you, even that kind of discussion is very controversial. It's hard to predict how the GCP versus Ohran will further, let's say, evolve to the possibility to even have some flavors. It's hard to predict, but I do believe that all the things, if you want to make anything happen, there should be some more open discussion. That would be more motivation to make it happen. In that sense, from my perspective, I don't have a good how to say prediction what could happen. I just want to emphasize that 3Q itself is open standard that is also contribution driven. Thanks.
Okay, thank you. And then I guess there's a lot of questions around IoT applications. It's hard to distill them into a short one, but maybe do you want to comment on what's your view on the sort of level of maturity of the IoT optimizations that 3GPP has done, and are they ready for implementation in chipsets, devices, and networks?
Yeah, thank you. Yes, are you talking IoT or IIoT?
I mean, I think we're talking about sort of NB-IoT and some of those related technologies.
Yeah, I mean, as mentioned in the earlier presentation, IoT and this two-flag EMT standard IoT has been enhanced for multiple releases. Personally, I do see a strong motivation to do the enhancements in the multiple releases, but this deployment for IoT typically aiming for a longer cycle. So in that sense, I think we're probably going to still see some enhancement here and there, but I'll say from the standard perspective, personally, I do believe it's already mature for deployment. We're gonna, I mean, even now we're talking about ERedCap and RedCap. We do have, from our perspective, we try to provide the optimized solution, targeting all kind of use cases, but at the same time, I do believe standards already provide a very good foundation to do some deployments. It really depends on the deployment, the use cases that you have in mind. I think with the current spec already give you a very good set of different flavors on possible deployments.
Okay, well, thank you.
Yeah,
so I think, thank you very much for that. So I think we will try and follow up on the questions we haven't been able to answer after the event. We will also, as I mentioned in the chat, be offering a replay for this, and I will try and talk to the presenters and see if we can share the slides as well. But I'd like to just wrap up today by answering a few questions, and in fact, come up with the chat on 6G. So we go to the next slide, please, Katie. So first of all, thank you very much for all the speakers. I want to shift gears and talk in the last few slides about 6G and what's happening there. And the first thing that we need to be clear about is that 6G won't be in the market until the end of the decade. But these technology and generational transitions have a very long lead time. So now is still a time to be looking at the early stages of what technology goes into 6G and what is its vision. So to try and address that and promote North American leadership, ATIS founded the NextG Alliance, or the NGA, with a goal to promote a 6G vision and a whole life cycle view for 6G that supports North American leadership. And that has been very successful and attracted a very broad ecosystem, including operators, vendors, hyperscalers, academia, government, and research labs. Earlier on this year, the NextG Alliance published a major report, the Roadmap to 6G, which is available at roadmap.nexgalliance.org. And this really lays out a foundation for the North American vision and path to leadership. Next slide, please. So what are the sort of key pillars of that vision? We've identified three main areas in the report. Firstly, a set of audacious goals, not just technical goals, but also, for example, environmental goals and social goals that can be achieved in 6G. Secondly, we have the roadmap, which is defining a path to connect every stage of the life cycle to progress towards the introduction of 6G at the end of the decade. And lastly, we are working on identifying what are the areas that we should prioritize to establish regional leadership. And this will go into a specific identification of research priorities that we believe should be undertaken as we move towards 6G. Next slide, please. So many people have asked around about the timeline for the next generation for 6G. So let me talk to that point. The first thing to say is that though 3GPP we expect will develop the eventual technical standards for 6G, they do this in a global framework which is managed by ITUR. And the ITUR name for this is towards IMT towards 2030 and beyond. And it's very important, I think, to say that we are in a pre-standard phase for 6G. So this is not work that is going to be coming into 3GPP this year or next year or the year after next. But as you can see on the diagram, this shows you the ITU timeline. And it consists of three main phases. So the first phase, which is really constructing the vision, is already being undertaken, and this will carry on through until about the end of 2023. Then between 2024 and 2026, we really construct the objectives for the next generation in the ITU framework. So these are what they call the technical performance requirements and how candidate technologies are assessed against those performance requirements. And then it's only really from 2027 and beyond that we get to the standardization phase. And this is the phase where organizations, and particularly 3GPP, will be involved in constructing actual specifications, implementable specifications of 6G technology. And these will be assessed whether they meet the technical performance criteria defined by ITU and adopted into the ITUR framework if they do. So we're certainly, some ways out from a 3GPP activity on 6G, and we really don't want the 6G activity to detract from the very important work which is being undertaken to enhance 5G. So next slide, please. So wrapping this up, I think 3GPP has really shown, and we've seen really excellent examples today of how the platform that was created for 5G is being evolved to enhance the performance, the efficiency, and to address new use cases. We haven't talked too much in this presentation today about the impact of COVID-19 on 3GPP's work, but I think that shows how well 3GPP has adapted, that we almost take that for granted, that we have been able to deliver Release 17 in the face of COVID-19. And this has all been done in a virtual meeting environment. So I think a major congratulations to the leadership and the contributors to 3GPP to achieve that work. We've also heard how Release 18 will herald the era of 5G Advanced, and talking about some of the differentiating technologies that will go into that. And then lastly, we are in the early stages of the next generational transition, but 5G will certainly dominate the market and normative standards work for another decade. But for 6G, now is the time to define the vision and the research priorities. And a lot of that activity is not in 3GPP itself, but in other organizations. And so we need to be aware of that. So that really brings us to the end of the webinar today. We will make the the replay available. I'd like to end by thanking again our speakers. We really appreciate their work in 3GPP and their expertise and knowledge sharing today. Also thank the ATIS staff who've been really helpful in bringing together all the technology and marketing for this event. And also thank you for the audience for your attention and your questions. We will try and answer as many of those as we can after the event. So with that, I think we are finished today, and thank you everybody. Have a good day.